Example 2.28. Show that the force on each plate of parallel plate capacitor has a magnitude equal to half QE, where Q is the charge on the capacitor and E is the magnitude of electric field between the plates. Explain the origin, the factor cube 1 by 2. Now, electric field of any charged plate, that is given by the equation sigma upon 2 epsilon 0. In chapter 1 we derived this thing. Now, when another plate is placed against first one, then we can say that second charged plate is in the electric field of first one, and there is charge Q. So the force on the second plate that we can write Q into E1, Q that is sigma into A. So we can write the force that is sigma into A into E1. So that is equal to sigma A. Now E1, that is sigma upon 2 epsilon 0. So resultantly we can write sigma square A upon 2 epsilon 0. So here substitute sigma, that is Q by A. So we can write sigma square, that is Q square upon A square into A upon 2 epsilon 0. 1 A is cancelled. So we'll get Q square upon 2 epsilon 0 A. Now divide numerator and denominator both by D. So Q square by D upon 2 epsilon 0 A by D. But this epsilon 0 A by D, that is C. So you will get Q square upon 2DC. Now Q square upon 2DC is replaced by Q by V. So 1 Q is cancelled. Take this V in numerator. So half into Q into V by D. But V by D, that is electric field E. So resultantly our equation, that is half into Q into E. Clear up to this one? Say, when the capacitor is charged at that time, the charge on the capacitor increases from 0 to Q. And therefore, the electric field established between two plates of the capacitor, that also increases from 0 to E. And therefore, the average value of the electric field E by 2 contribute in the force. And therefore, this factor 1 by 2 appears here. Clear to all of you?